Conjunction, and, is the second of the 5 connectives used with truth tables. Unlike not, and links two symbols that stand for statements together. While some use a plus sign to symbolize and others use an ampersand, we will use this symbol, an upside-down V, which you can type by holding Shift down and pushing the key for the number 6 on the top row of any keyboard. Let us say that A stands for I have an apple, and B stands for I have a banana. This means that A and B stands for the statement I have an apple and I have a banana, which is the same as saying I have an apple and a banana. With not, we had one statement with 2 possible cases of truth value. With 2 statements, we need 4 possible cases of truth values. We use this set of 4 cases in the same standard order for any truth table that involves 2 symbolized statements. In the first case, both A and B are true. In the second case, A is true and B is false. In the third case, A is false and B is true. And in the fourth and final case, A and B are both false. To avoid making mistakes, before we start solving any truth table, we write the truth values for each symbol underneath where it appears in the expression we are evaluating. Just as we did for not A, we can also write the opposite truth values for each symbol underneath where it appears in the expression with a not. In the first case, it is true that I have an apple, and it is true that I have a banana. And so the conjoined statement, I have an apple and I have a banana, is true. In the second case, it is true that I have an apple, but it is not true that I have a banana. And so the statement, I have an apple and I have a banana, is false. Notice that in everyday language, we could say that I was half right, and my statement is a half-truth. But in formal logic, we can only give absolute truth values to statements and sets of statements, so we must say that the entire statement is false. In the third case, it is not true that I have an apple, but it is true that I have a banana, and so the statement, I have an apple and a banana, is false, for the same reason that it is false in the second case. It is only a half-truth, not fully true. In the fourth and final case, when it is not true that I have an apple and it is not true that I have a banana, the statement, I have an apple and a banana, is entirely false. Notice that the 4 truth values beneath the and symbol are T, F, F, and F, the final answer for this truth table. We can demonstrate that contradictions are false in formal logic with the following truth table. To begin, we write T and F below A and F and T below not A, where they appear in the expression. Whenever we have an F on either side or both sides of an and, the conjoined expression is false. Because either A or not A is false in both possible cases, A and not A is always false. A and not A contradict each other, and so they cannot both be true at the same time in formal logic.